Okay, the last tutorial parts that we're going to machine would get you ready for building your hamster box as you want to deem it, or the card box. But anyways, I've already got my origin set up, and obviously this is a three-dimensional toolpath. So right next to the 2D panel, there's 3D panel. And if we look at this, there's a whole bunch of different toolpaths and strategies that you can use to cut multiple 3D contours. So there we have adaptive, pocket clearing, steep and shallow. That one looks interesting and might actually work pretty good for this particular part. The traditional one that a lot of other programs have, and that's the primary one to use, is the parallel. The parallel is sometimes called a parallel lace. As we see here, that scalloped contour. In order to follow that three-dimensional contour where that part is lofted up, you would have to do a roughing cut, 2D cut, down to the outer dimensions, and then just go back and clean it up afterwards. So it still would sometimes take multiple tool paths. But again, we have all these different tool paths, and every geometry that's created might have a different way that is the best way to cut it. And it's always a combination of surface quality versus speed and time that it takes to do the machining. So on this one, I am most familiar with the parallel, so that's what we typically use, although you could experiment with the other ones if you want to. So I'm going to select, we're going to do a parallel. And because those contours in multiple depths are rounded, we're going to want to use tool 5 or 6. Probably need the long reach ball nose. So that's a 1/4 inch ball mill. So we'll select tool number 6. Okay, for the geometry, we can probably just use the silhouette. And I'm going to make some mistakes on purpose. So we see what happens. For the bottom height, I'm going to go stock top, and I'm going to go down -1/2 inch. Okay, and the reason I'm going to go -1/2 inch down, when I go to my passes, this time I am going to use stock to leave, and I'm going to leave 1/8 inch on the wall and on the floor. Okay, so that's going to be cutting 3/8 inch down. Step over is 1/8 inch step over. So that's going 3/8 down, and 1/8 inch would be pretty aggressive. We could do that in a softwood, probably not in a hardwood. Okay, I say okay. And I got the negative in the wrong place. -1/2 inch down. We say okay, and we see it only cuts part of the tool path. It is following that. It's going 1/2 inch down, but it's leaving stock on the wall and on the floor. So there's one thing that we did not do. And on the geometry tab, you see there was this checkbox, contact only. We'll use this on one of the other ones. There's also like avoid touching or touching surfaces. So there's all these different checkboxes that we have. And when you get into three-dimensional tool paths, there's even more boxes available for us. So the good thing is we can always see what the tool paths look like before we actually decide to make that cut. We can see what it's going to look like in simulation. Okay. So we see it in simulation, and we can see clearly it is coming up and above the surface that's there because we had that stock to leave selected, and it's on. It only comes down to this level here. Okay, so I've got pretty good settings for what's actually happening. So what I'm going to do then is, and it's leaving all these cusps in there, but that's okay because we're going to clean that up with our finishing pass at the end. So then I'm just going to right click, duplicate that toolpath. And then when I edit it, now I'll go ahead and go down -7/8 of an inch, negative 0.875, still leaving 1/4 inch. And I say okay, and we can see that toolpath now cuts deeper, but you see it's also a bunch of wasted time. And I guess we could look at these if we simulate them one at a time. That first parallel toolpath is taking a minute. That second parallel toolpath, if I simulate just that one, it's also taking a minute. Okay, and there's a lot of wasted space as it's going around on this side. So there's another change we can make. I'm going to go into Edit, and then I'm going to go into Rest Machining. I'm going to check that box. So that's going to not cut the part that now is just cutting in air. So I'll say OK. And now we see the part that was just cutting in air, it doesn't make that tool cut anymore. If I simulate that where it was taking a minute because half of the cuts were in air, now it's only taking 29 seconds. Okay, I'll go ahead and duplicate that toolpath again. This time it gives me an error because it's actually exactly the same cut. And I need to figure out what level I need to go down. I want to make sure I come down to the bottom of that trough. Of course, I'm still going to leave an 1/8 inch on the floor and on the wall with stock to leave. So, of course, I'll use my inspect tool. So this time that is 325 thousandths from the bottom that curve extends. So I'll go ahead and say close, and let's edit that path again. So on my heights, let's go now stock bottom and offset it 325 thousandths. So there we go. That's the right measurement. And I think that's the only thing I need to change. So then I have another little parallel toolpath. And we're going to have one final parallel. We'll go ahead and duplicate that entire, or that last parallel. Go ahead and go in and edit it. This time, we're going to take off the rest machining. And the heights are good. The passes is what we need to change, where we'll take off stock to leave. And we're going to make our step over a distance of maybe somewhere between 30 and 50 thousandths. And this is all going to be, let's put in 50 thousandths at first. It's always going to be a decision between the time that it's going to take to cut versus the surface quality. One of the other things that we can do with this toolpath is cut in a different direction. So here we're cutting 0 degrees, so we're going back and forth this way. We could go at a 45 degrees, at a 90 degrees. If we went 90 degrees, the tool would run back and forth in a parallel Y direction, whereas now the toolpath is basically running in the X direction. So there's another little thing you can do there. And again, every shape that's designed has its own geometry. So sometimes one strategy works better than another. We'll go ahead and say OK. And there you see that toolpath without the stock to leave ends up being, let's see, did we get that turned off, the stock to leave? We did. Okay. So then there's the final toolpath. And now We look at that one. We look at just, now let's just simulate the whole thing. Simulate. Whole thing is now 3 minutes long. And let's see, we have our stock on. We go ahead and press play. And we can see that obviously that 3/8 of an inch deep is probably a little bit aggressive if you're cutting hardwood. Speed this up. And now you see we do get little cuts in there. And actually, as we look at that in the surface quality, just because of the way the ball mill is working, it probably would look a little bit better if our direction was 90 degrees. And then we could even change the step over and make it maybe 30 thousandths of an inch. Not 3 thousandths, 30 thousandths. Okay, so we see that goes back and forth, and see by cutting this way, our contour is basically following the shape of the ball mill this time. Let's see what that in total time goes from. Total time went from 3 minutes to 3 minutes and 47 seconds. And I'll bet the surface quality, simulating that, probably looks a lot better. So there's your roughing cuts. And just looking at it, the edges that are left, cutting at a 90-degree angle, there's still some little cusps there, but it probably looks a lot better cutting at 90 degrees versus 0 degrees for that finish pass. All right, so there's the simple contour. We'll look at the other shape, which is very similar to your card box project in a minute.